Hey guys, I just want to do, seem to be a little bit of confusion about the air system. I've never really done a close-up of how I've got it set up and the valving and the lines and the air tank and all that stuff. So I'm just going to start with the machine sitting here right now. It's running because I'm going to be doing a lot of manipulating with the system, so the air compressor is going to be running while I show you all this. Let's see, so yeah, we've got the dual shocks, and those are actually the new Delco shocks I just put on there, which are just relabeled Gabriel hijackers. So we got dual shocks on every corner. Right now, I've got the machine set up for a pretty soft ride, there's the limit straps I put on it right here. I don't like them. See how they work. But anyways, so right now the machine's probably sitting pretty close to a stock ride height, and I've got it compensated a little bit for when I'm sitting in it, because you can notice it's probably leaning a little bit to the passenger side, but it's sitting on unlevel ground. But anyways, so the valves. The way I have my valves set up, I've got a valve for each shock. So these are Hoke valves, so they're either open or closed. Right now everything's closed, so every shock is isolated from each other. If I open up the two rear valves, what that does is it joins the rear shocks side to side. So now if I'm going over obstacles, it makes it articulate better, because if one wheel goes up, the other wheel, it transfers air from that side over to that side, and it pushes that wheel down. So it helps keep traction as much as you can even to both wheels. So it's almost like a solid axle. It pivots in the middle. If you put it back and close the valves, now it's just like having regular air springs. If one wheel compresses, it's just compressing its own air. No air goes anywhere else. So, except the air lines that go up to the front to the valves. So it's one of the reasons I said you should not use bigger than the air lines that come with the shocks. These little buggers right here. If you use big air lines going from the shocks up to the valves, you add a lot of volume, and I know it doesn't seem like much, but it adds enough volume to where the shocks just have no compression resistance almost at all. The shocks have a real low volume of air, so any volume you add to that shock set just makes a huge difference to how it supports the machine as an air spring. These were never designed to be air springs, so we're really, you know, we're in unknown territory here. But you don't want to add volume to the air shocks as much as possible. I mean, if I could move the valve, you know, if you had electric valves, you would mount the electric valves as close to the shock as possible, and that would make it work even better as an air spring. But, you know, you start talking more money and more complexity. So right now, Amy, you want to take this now? Stay on me.
Mm-hmm.
Right now what I've got is an air compressor mounted here. Now, of course, you don't have to mount the air compressor here. Come in. So the air compressor's here. I've got a pressure switch here, and then the air compressor goes and basically just tees into the system. The valves are what control the air going anywhere, except the compressor sees the air tank at the back. Right here, this is a 2.5 gallon air tank. Adding this air tank made a huge difference to how quickly the machine responds to opening and closing the valves and adjusting the height. Mostly because it gives you a big reservoir of pressurized air, and you're not just counting on the compressor to do all the work. It pressurizes the system to 200 psi and it shuts off because of the pressure switch. The compressor kicks back on at about 160. I had to buy that switch. I had to find the control switch separately from the compressor. Most systems don't go to 200 psi for what I could find anyways. So anyways, basically the air compressor and the tank are tied together. They're both keyed into the valves over here. So come around here. This valve right here, when I open it, it opens the air to the manifold that these valves are connected to. These is the right rear, front right, left right. This is the exhaust valve. Also, since I have a separate exhaust valve, with this system I was able to mount an extra line coming off the exhaust valve. So now I've got a spool of air line in the back. So now I can inflate tires or whatever I need to do. It's just sitting there. It's got a quick connect on it. Really simple to use, and it's really handy. It's nice when you're on the trail for tinkering with air pressures in the tires. If you're into rock crawling, I mean, that's what I like to do. It's just climbing over obstacles. Obviously, if you're going to do a lot of road running or just ripping down the trails, you want to put more air in the tires because it just reduces the rolling resistance, makes the machine faster. Anyways, so that was my main reason for going with the individual just on-off valves. So right now, if I open up this valve, now the manifold, and I don't even know if we can see the manifold, it's up under here. There's the manifold right there, and it's tied into the valves, and the connector, the manifold itself is this little plastic thing right here. I don't know if you can see that in there, Amy. Can you see that?
I think so. Mm-hmm.
So what it is you can see the small air lines coming up to the valves. You've got a pressure line going to the manifold, then a pressure line going to the control valve for pressure. That's this one right here. So if I want to put more air in the front shocks, just opening one does absolutely nothing. Basically all I've done is open that shock to see the manifold. Now if I want to raise the pressure in that shock, now I have to open the tank valve basically, or the pressure valve. So I open that and up comes that side of the machine. So it's leaned it over this way. Now if I want to drop that side of the machine, this is my exhaust line. Now I just twist the exhaust and I can level out the machine again. So when I'm done monkeying with that shock, I close the valve. So now the shock is completely isolated to itself. If I want to get the articulation mode, I open up both front shock valves. So now this is coming over through there, it goes to the valve, it goes through the manifold, through this valve, and down to this shock. So now you've got much easier articulation, but less roll resistance. So when you're running down the trail or trying to, cornering and going fast, you need the shocks isolated because now they've become individual air springs. When you open it, instead of individual air springs, now you've got a solid axle that pivots in the middle. It works the same way. So same with the rear. If I'm going on over an obstacle and I'm crawling, I've articulated the front, I get the front up where I'm going to go. If it's a real sticky situation, you slap these down, now they're solid. Then you open up the rear valves, and the rears can do the same thing, pivot in the middle. What you can't do is open all four at once, because what's going to happen is the rear's going to go down, and the front's going to go up, because the rears require a lot more pressure to maintain the same ride height as the front. I'm guessing. I don't use pressure gauges except when I initially put the system together. The rear generally takes 140 to 160 psi depending how much load you got and how you're driving. But if you open it now, watch, the front is most likely going to come up. Now it didn't, it's near the top. But the rear will easily go down. If I step on it, it just sags and the front comes up. Because all I've done now is I've got all four shocks basically seeing the exact same pressure. So you can see the front shocks are completely topped out in their travel now. There's the line where they were. So both the front shocks are completely topped out in their travel, and the rear shocks are sagging. And if you put any weight on it, it'll just sag right down. It has no air spring resistance at this point. The other problem, if you have all four shocks seeing each other, in other words, they're all joined to a common air supply now. And when you put weight on one side of the machine, there it goes. It just falls right over. It has no roll resistance because all of the air in the system just goes to the side with the least amount of resistance. Now if I get this thing leveled back up, and look at how easily it tips. I mean, it's got nothing. If I get it leveled back up, I'm going to close the valves now. I'm going to put the fronts back where they should be because they've got too much pressure in them now. So I drop the front, the rears are isolated, but I'm going to go ahead and pressurize both rears and get the rears back up where they should be. So I've opened the rear valves, right and left. Now I'm going to put pressure into my pressure exhaust. Pressure goes into the rear, up comes the machine in the back. So now all four are isolated. I can put a little more in the front, the machine comes up. And now when I hang on it, it doesn't flop over. It's got a lot more resistance to roll. So yeah, it makes a big difference. That's why you can't have all of the shocks seeing each other for one thing. The other thing you can't do, even if you isolated front and rear, is you can't have both sides seeing each other all at once because all of your lean resistance, all of your load resistance is gone. I mean, it just, like I said, the machine will just lean to the side with the most weight on it. So that's why I've got 6 valves. And again, just to for instance, if I want to lower the whole machine, open all 4 valves, and you're not riding it now, you're just lowering it, say to get it into your car hauler or something. Exhaust valve, see right now all 4 are open, nothing's happening. I have to open the exhaust valve and the machine goes down. Down it goes. So that's with all 4 valves open and then opening the exhaust valve. Now to bring the machine back up, the exhaust valve is now closed. All 4 valves are still open. All 4 shocks are still open to each other. To just bring the machine back up, now I'm just going to, I'll open, still all 4 valves are open. Now I'm going to open the pressure valve so that the air tank and the compressor now send pressure to the manifold, and the manifold goes through the valves, and because all 4 valves are open now, the machine comes up. It's never going to come up perfectly evenly, because obviously, because right now everybody's seeing each other, and that's it, it's up. Now, so that's how the valves work, and why with a 4-wheel system, I can't think of any other way to have control over the system properly with less than 4 valves. They make valves that do pressure and exhaust in one valve. They were more expensive, and at the time I was doing this as cheaply as possible. Those probably would work fine, except the advantage with this was, with the common exhaust valve, I could open it to an air line and run and do things with air off the machine. That was one of my main considerations for having everything going through individual valves that are just open or closed. So that's that. Let's see, I don't think... Oh, again, the other advantage with having this coming towards the front, and I've actually had to do this when I broke one of my shocks. What I did was I opened the valve. It was actually the right rear, but we'll do the left front. Open this, and again, you can hear the compressor running. Right now, all the compressor doing is repressurizing the entire system on its side. So it's filling the air tank and pressurizing the line all the way up to the fill valve. So now I've got my left side open, left front. I'm just going to let all the air out of that shock. The machine is still, the rears will still hold it up. But now there's no air in this left front wheel. Of course, the machine's going to lean this way. But if you're on the trail, and especially if you got somebody with you, and you need to get a tire moved, just pick it up. It's off the ground. Stick something under it, you can yank a wheel off. Of course, you can pressurize. If you pressurize that, I can make it even more exaggerated, I'm pretty sure. If I put more pressure in that one, pressurize that up as hard as it'll go. My limit straps really, I really don't like them. But anyways, then I can drop the air on that corner to make the machine teeter on that wheel and that wheel. So if I drop the air on that corner now, so I've got all the air out of that corner, I can actually push the machine that way. And look at this front wheel. I can get this front wheel right off the ground. If I needed to change a tire on the trail. So there's a lot of cool stuff you can do with this air suspension that, you know, I'm still thinking of things I can do with it. And again, when I was out on the trail, I was in the middle of nowhere. Of course, I had nothing with me and was by myself. Didn't even have my phone. And I busted the shock on the other side. Well, thank God, because I was able to do basically the opposite of what I'm doing here. I was able to get that rear wheel off the ground. Everything leaned over this way, and I was able to get the shock loose and back into its tube and limp the thing home. Otherwise, I was done. So yeah, this is really cool. So anyways, now there's no air in this one. There's no air in that one. Now I'm going to air that one back up. Open the pressure valve. Up she comes. And then, see, that opens this one. That is the left front wheel. And then put air in the left front wheel and up it comes. That's the advantage with multiple air valves and being able to isolate each corner. And honestly, I don't know how you could do it any differently. They really have to be isolated. Each set completely isolated from the others, except when you're doing specific operations like, you know, you want improved articulation, you know, you need to change a wheel or whatever. Otherwise, if you left them all joined together, it would just be a sloppy mess and it just wouldn't work. It just plain won't work. So, anyway, this air compressor, I don't have my glasses on. This is it's a 200 PSI compressor. Again, it comes out of the compressor. I have a control switch right here, and this air line, and there's the T. The T goes to the manifold. This line goes to the manifold. This line goes back to the air tank. So basically, the air tank is just a big accumulator, well, which is what an air tank is anyways, but in this system, it's just a big accumulator. The other, I've had guys ask me, you know, what about putting, you see these big lines, these large lines, these 1/4-inch diameter lines. The only place I use these 1/4-inch diameter lines are on the air supply side. If you look at the valves, all of the lines coming off the valves are the little 1/8-inch lines that come with the shocks. You want to keep, again, you want to keep the volume of air that the shocks are seeing as low as possible. If you were doing a, no holds barred, money's no object system, I would have a control valve on each corner of the machine as close to the shocks as possible. That way you could run a 1/4-inch line to the control valve and then have a very short distance of 1/8-inch line, and it would increase the air spring capability of the shocks. I think would be noticeable. I think it would work a lot better. But still, even though I've got air lines running all the way back to each pair of shocks with a T right above the shocks where the two shocks join together, it's still pretty good. I just think it could be better. Of course, anything can be better. It would be better if you had this, if you wanted to go to the extra expense to put in the electric control valves. That would be really cool. Same thing though, you'd still have to have a valve for each individual wheel so that the system only sees each other when you want it to. If there's any questions, just post them and I'll answer them as best I can. And you guys, some of the guys have already made improvements to this that are really cool. Replacing the bushings in the shocks, because the stock bushings in the shocks that they come with are a mushy mess. We've now found, I say we, one of our members has now found a set of bushings that's a straight swap for those. Highly recommended. Highly recommended. Anything you can do to get the sponginess out of these shocks is going to be a big improvement. Not just to the functionality, but to the life of them. When I took my rear shocks out, the bushings at the top were just completely mashed down to nothing. So basically, the bolts, the retaining bolts, were pretty much metal to metal on the top because they had just pushed their way all the way through the cheesy bushings they come with. That's about it. Thanks. Hope it helps.